certainly guilty of that for a number of reasons. Andy, Matt, and I, I'm good. Andy, Matt, and I welcome everybody today, and we thank you for your support. And Tim, sorry. Clearly, and Tim. Thank you for your support and joining us on a Saturday, which I know you could be doing something else at. So, again, welcome. We have Lee Howard, who will be our keynote speaker on IPv6 and Linux. We look forward to hearing what he has to say today. Andy, any other points of order before we get started?
No, you can just progress through the slides.
Yeah, here we go. Yep, sign in. I know we had trouble with the parking. Hopefully we will, hopefully nobody gets towed.
The other entrance is working.
The other entrance is working, okay. I think it's run out and do that. It depends how paranoid I guess you are.
Well, I had to call in and they just opened the gate. So I don't have a ticket, so I don't know how I'm going to get out. But
You have to call out, yeah.
Okay.
Yeah.
Run it.
Yeah. As always, we are being streamed live. Thank you very much, Tim. We appreciate that. Meeting notes provided at the link below. You can pop them open and follow along if you found the font to be too small up on the screen. As usual, our socials and links for Novolog. Know your Linux distributions. I didn't read through these, so.
You want me to do this?
Yeah, if you want to handle the.
All right. Yeah, I forgot. I forgot to even put these in there. So. All right. So this is the icebreaker we're trying to do. So this is know your Linux distributions. It's a bunch of questions. So what year did Linus Torvalds first release the Linux kernel? Yes.
1991.
84 is it? No, it's 91. 91, that's pretty good. So, all right. So in 1992, he released 0.12 Linux kernel, and that was the first kernel to go into a distro. What was this distro?
Puppy.
Excuse me?
Puppy.
Puppy? I don't think so. Anybody? You're very close. So it didn't have a name. It was H.J. Liu, and he had it on two 5 1/4-inch discs, one for boot and one for root. So here's a good question: who has a 5 1/4-inch disc now? Tim. All right, and you too. What's your name again?
Joe Klein.
Joe. Okay. So 8-inch.
No, my wife burned all mine.
My dad has them in his garage with the verbatim hard cases.
So I hear that the current Linux kernel doesn't even have the floppy disk drivers in it anymore. So
I still have the floppy disk drive.
we need to get the 012 kernel because that's what's going to work with it. So anyway, so the second Linux distribution came out in 1992 with the same kernel. What was that? Nobody? That was MCC Interim Linux, Manchester Computing Center Interim Linux. Yeah, I'm going to take it no one actually ran that. All right. So, what was the third and fourth ones, which also came out in 92? Getting close.
Mandrake, Susie?
No, that's all later names.
Tamu and SLS. Yeah. All right. So, anyone ever run any of these? No? Yeah, you guys.
Yeah.
You ran Tamu or SLS?
Yeah, it was SLS. At that time, we got code. Well, on my Solaris boxes, we basically had a code for something called a browser, and we were trying to do porting, but there was just not enough space.
What's this browser thing? Just kidding. All right. So, what distributions evolved from SLS Linux? Yeah. Just keep saying Slackware. You'll get the answer right eventually. And Debian as well. They both evolved from Slackware. Okay. And I was going to ask, did anyone ever run Slackware? But Tim's running it right now, apparently. So, yeah, what I remember is Slackware was, that was a big deal when I started getting into Linux. And then once the CDs came out with Red Hat on it, everyone just kind of abandoned it. So, I think that's it. You have a CD with Slackware? I remember it was like 13 discs. So.
I just remember getting a magazine rated on it. Pretty sure. It was one of those weird, like, European magazines.
Weird Europeans.
They don't make fun of our European counterparts. Let's see, call for presentations as always. If you have something interesting to share with the group, apparently it can be from 15 minutes to 1.5 hours. You're brave if you do 1.5 hours. The earlier discussion got me thinking about a presentation. I have a new laptop coming from Star Labs, if they ever get it to me, which is supposed to be all free open source and, open source Libre boot and stuff like that. So I'll report back once I move into my new work laptop. Topics can be from beginner to advanced. I think we know generally, what the feel of the room is. So if you have a topic that you think that could be shared, please propose one, and it'll probably get accepted. Any shine of your choice? What does that mean?
It means you don't have to, we don't care about the polish.
Yeah, 80-20% rule. Get it on paper, get up in front of people. It doesn't need to be like, IETF edited, down to the nth degree.
Maybe suggestion, don't do it during home.
So, see Andy after the meeting, or since Andy, I think, is leaving early, please see me if you have any desire for that. Thank you. Upcoming prezos, March, Lightning Talks Geekathon. Send me a title for your Lightning Talks. These are short talks that any of us can give. Again, these are sub 15 minutes, can be, right? And don't even have to fall into the... I might do one either around my new affiliation. So for those of you who do know me, I ended up getting a Christmas miracle and ended up getting a job at Quad 9 just before Christmas. So came into the new year very happy on top of everything that else happened to me last year. You can find out over coffee later. But yeah, I'm now pimping Quad 9. Everybody move to Quad 9 DNS. I can tell you all about it after this meeting.
And in April, Matt is going to do one on mobile Linux.
Okay, right on. Help spread the propaganda. Always bring a friend. See if somebody wants to come. I know that we continue to put out the word to get more bodies in here. I think we're doing a pretty good job. I continue to see a lot of the same faces or some new faces. Welcome, Frankie. So, yeah, more bodies is always a good thing for any organization. Main presentation, Professional's Guide to IPv6. I want to introduce a good friend of mine for many, many years, Lee Howard. Please take it over.
I got a question real quick. Who's going to Southeast Linux Fest?
Have they said it this year already?
Not yet, but I expect them to.
When and where is Southeast Linux Fest?
It's in Charlotte, and it's usually
July?
June,
or July?
July. Yeah.
Yeah. I don't think they've set the dates yet.
Okay.
So.
Are you going?
I plan on it.
Oh, right
I
on.
didn't get to go last year because I had something else I had to do.
Real quick.
Who's hiring? Who's looking slide? Did that disappear?
I disappeared it, yeah. But if you have, before Lee gets started, if you have a job or something, you have a job opening, raise your hand.
Are you looking for somebody, Ed? No. Oh. Are you looking for yourself?
Anybody looking for work? Okay, we've got a few.
Yeah.
You want to ask what they're looking for?
Yeah. What specifically are we interested in finding?
Cybersecurity.
I'm a developer.
A developer? Okay. Frankie, didn't a role for cybersecurity just open up at Aaron? Senior role? Yeah. If you're interested in,
Well, I don't know if I can handle a senior role, but
well, you never know. Take a look at it online. Maybe talk to Frankie about the position that opened. I am looking for, at Quad 9, we were looking for a junior position for somebody to handle Zendesk tickets and look at issues with resolvers that we have placed around the world when people open up tickets and say, hey, I'm experiencing problems with Quad 9 in, Mozambique or whatever, to help troubleshoot with people, follow up after with me. I think it's probably a job if one of us has kids that, following in our footsteps, it would probably be a good role for somebody like that who's familiar with the Linux command line, as well as doing things like, trace routes, pings, MTRs, and, kicking, daemons on a Linux box. So if you know any young people like that who are interested in our business, let me know. I can point them at it.
I'm only 12.
Only 12? You're perfect.
Darren, I have a question for you.
Yes, sir.
You said you work for Quad 9. What's that mean? What's Quad 9?
Advertising.
I make
No.
the assumption that most people understand how, that we need DNS in order for the, your computer to work, just in general. Unlike Quad 8 by Google, which everybody points at, Quad 9 has a mission to support free, open, anonymous connectivity around the world via Quad 9.
Where'd the name come from?
The name came from the fact that the IPv4 address is 9.9.9.9.
Do you have an IPv6 address?
We do have an IPv6 address. We have a couple IPv6 addresses.
Not quite as easy to remember, are they?
No, they are not quite as.
What do you do when you can't remember the IP address? There's a little,
You look
there's
it up.
in the DNS.
In the
There's a little
DNS.
chicken and egg problem here.
True. The other issue I ran into is using secure DNS on my mobile device. You have to put in a URL and not an IP address, which is quite frustrating because I have to back that out every time I'm behind any sort of I ran into this on the United flight. I had to disable that in order for my phone to be able to attach to the Wi-Fi on the plane in order to, purchase the product, and then I could go back to using it. But yes, thank you for asking what we do at Quad 9.
Hi, my name's Lee. This is, as you can tell, I like a very informal kind of structure. So if it's what kind of polish. I've got a mix of slides from a whole bunch of different presentations that I was trying to put together and figure out what kinds of things would be interesting to this particular group. Please, jump right in, bust my chops, ask questions, give me a hard time about the poor formatting of slides or whatever else you might like. I'll do the bio. I usually find those to be boring, but I feel like I have to do a little bit of it. Some years ago, I was at Time Warner Cable. I was working on developing technologies. My job was to take technologies that are in progress of being developed and get them ready to be actually introduced into production. Worked with Darren there. As I was doing that, I sort of went, we can see that Aaron is about to run out of IPv4 addresses, and we're not going to be able to get more. We think we're a growing company. We sort of hope to be adding services, which means devices. What are we going to do then? We're going to have to do we're going to have to do IPv6. And so my boss said, yes, we are. Go run that program. So I ran the IPv6 program for Time Warner Cable. And by the time I left, we deployed to 5 or 6 million users, which felt pretty good at the time. One of the largest networks in the world at the time. And then while I was doing that, I was. Yep, thanks. I co-chaired the V6 Ops, the IPv6 Operations Working Group at IETF. Co-chaired the IPv6 Renumbering Working Group at IETF. Shut that down too early, I think, in my opinion, in retrospect. Yeah, but now I work for a company called IPv4.Global, which is almost a little embarrassing. We're a broker of IPv4 addresses. I can connect the dots a little bit. I love to come in and help companies deploy IPv6 so that they can sell their IPv4 addresses. Because you've got a /16 in IPv4, that's worth $2 million, maybe $2.5 million. That's real money, and that sort of helps the funding along the way to deploy your IPv6. So one of my legacy slides here is I'm not going to have you reading device configurations in 2 hours. That's not really my goal anymore, but I'm going to try and cover a lot of different topics. And part of it is just I have a feeling that most people here, actually, how many people here have actually deployed IPv6 in anger? in real life for real reasons. Okay, so a few folks. Right. Right. So yes, that's the kind of good. So most of us then have not done much with IPv6. Maybe you've seen it, you've heard of it. So I'm going to talk a little bit about what's going on. I think after the last Novolug meeting, I was walking out the door, and a couple of folks were talking about this session and said, is IPv6 ever going to happen? So I decided, all right, let me include a little bit of, is IPv6 ever going to happen? So this is, I like to give the citations down here. Google.com/IPv6 gives you their measurements. This is what percentage of hits on Google properties are arriving over IPv6. And it's a little bit small here, but This top line is the 50% line because that's the line we're approaching right now. So globally, worldwide, traffic hitting Google is a little over 45%. So IPv6 has been deployed at scale in lots of different places. And so it's not just someday this is going to happen. It actually is happening. There's some other things that I think are really interesting in this slide. It's got this really shaggy line, right? I find that to be really interesting. And if you really zoom in, what you find is that on weekdays, the percentage of hits over IPv6 is on the lower end. And on weekends, it's on the higher end. Well, why is that? It's because, yeah, what, go ahead. Phones, yes. Every major ISP in especially North America, wireless carrier in especially North America has deployed IPv6 essentially ubiquitously. You've got to have a really old unsupported handset to not work. Also, residential ISPs, by and large, I'm going to come back in a minute, but by and large, residential ISPs have a high percentage of IPv6 deployment. And in case you're going, I'm not sure about that, you can also see some of these little gaps here where there's this short period that's a little bit higher. Turns out, between Christmas and New Year's every year, the bottom kind of rises because people aren't working from the office those days. So it's really interesting there. Deployment curves, like when you're deploying a new technology and trying to see how rapidly it happens, those tend to be S curves. So you see a long, slow nothing, and then a steeper rise, and then it tapers. If you squint, you might see a little bit of a taper, but I kind of go, that looks pretty linear to me. If I'm looking at this line, it's pretty darn linear in terms of the rate of deployment of IPv6 globally. It's a little bit flat in the last 9 months, but you know what? We kind of see that pattern in previous years as well, where there's a flat period where people are consolidating, doing their planning, and then there's another burst of deployment. Sir?
You also have the other issue is the consumer expo.
Yep.
That basically, after they start selling it, you see a big increase.
Oh, okay, interesting. Yeah, so people buy their new equipment and bring it home, and it supports v6, and suddenly you see more traffic using v6. Yeah, so one of the things that is interesting is one of the limitations in greater numbers of deployment is that a lot of consumer electronics are using some kind of compressed kernel that doesn't include v6 for no particular reason other than consumers aren't looking for v6 on the box before they buy a TV or a game console. They're just buying because it has the features they care about. So the device manufacturers don't really care. The Internet of Things, which a lot of people have described as being a major driver for IPv6, is not using IPv6. It's mostly using private addresses on NAT. And in many cases, you're seeing those devices being behind a proprietary NAT on on Zigbee or some kind of proprietary network before connecting to the rest of the internet.
The 6 to 4 thing. So
Yeah.
has that ever risen above 0% or?
Actually, thank you. It was back in the 2008, 2011 kind of time frame. There was a concern that a lot of people were behind 6 to 4 or other transition mechanism, and that was hiding maybe some of the deployment numbers. So back in those days, yeah, maybe it was 2%, but it was, well, actually, let me take that back. It might have been 2% of all hits, but not 2% of all traffic at the time.
So is that because they have v6, right?
Right.
So anyone who's on v6 is going to hit their v6 endpoints. Is it fair to say that if you don't have an IPv6 service, or better yet, your service on IPv6, you're not going to see people who only have v6. You're not going to see that traffic.
Right, and that is the biggest inhibitor to IPv6 deployment, if you're trying to get IPv6 deployment, is that IPv6 is not backwards compatible to IPv4. And so if you want to reach, if you're trying to roll out IPv6 and you want to reach, I'm going to talk about transition mechanisms a little bit, but if you want to reach stuff that's the legacy internet, then you have to have some kind of translator someplace. Somebody has to be doing that translation. Or what most people really do is deploy dual stacks. You've got both stacks running on your device at the same time. Another question? Yes?
So has every address for IPv4 been assigned by now, or?
Great question. More complicated than you might think. So of the, sorry, sorry, Andy.
All right. Oh, no.
Oh, there we go. There are 5 regional internet registries. Technically, Afrinix still has some addresses. IANA has given out all the addresses to the 5 registries. Technically, Afrinix still has some, but I believe they're not handing out more than a /24 at a time. And so they're not really giving them out very much. They also have some governance issues right now that are in the process of being hopefully resolved. All of the other registries are completely out of IPv4. Aaron, for instance, has a waiting list, and so every quarter, if they've reclaimed IPv4 addresses from organizations that have addresses but aren't paying or whatever, they'll give out whatever they have. On average, I believe the current fulfillment rate is when you get on the waiting list, you wait for about 2.5 years on average to get that address. So it's a long time, and that's why there is a market for IP addresses. Right? People do still need IPv4 addresses. That said, there's also an effort to reclassify some of the. So there's also a lot of people who got a Class B or a Class A back when we had classful IPv4 addressing. So a lot of organizations that got a lot of addresses in the 90s or 80s aren't using all of those addresses. And that's a place where I see a lot of universities that have 65,000 IPv4 addresses, but 5,000 students. Great market for me. There is an effort to reclassify some of the other unicasts, but there's, the IPv4 ranges include, basic unicast space, and there's a multicast space, and there's Class E's experimental, and there's an effort to reclassify that address space to be available for global unicast. It seems like it's a little bit stalled right now, and there's been concern that there's hardware out there that still won't route it. That's been coded, configured to not route that space because it's considered bogon. And then the Department of Defense has an awful lot of address space, and I am not cleared to know how much they're using. Yeah?
Is the internet backbone, is it like a 90% IPv6 support, or maybe you're answering?
Yeah, pretty much. So there is no single internet backbone, and I realize this chart's very hard to see. So there's, I'm just going to take your question and go to this. So APNEC, the Regional Internet Registry for Asia Pacific, their chief scientist is Jeff Houston, and he runs some experiments. He's buying ads on Google, and the ads are nothing. They're blank. They're 2 pixels. 1 pixel is only available on an IPv6 server, and 1 pixel is only available over IPv4. And so he will say who's fetching the IPv4 and correlate that to who's fetching the IPv6. And then he can, because he knows the addresses, he can then correlate to which network they're coming from and figure out the relative IPv6 availability among a lot of different networks. So that's why I wanted to, so this is his chart. He does include some colorful maps on it as well. Oh, I forgot to say, one more thing I forgot to say about Google. Yesterday, I think it was yesterday, the United States broke 50% for the first time. So more than half of traffic hitting Google as of yesterday is over, in the United States, is over IPv6. So this chart shows something a little bit different. This is, he's got it broken down by network, and this is the name of the autonomous system number, so it's who it's registered that way, so it's a little bit hard to read. The first one's pretty easy to read, it's Comcast. And 84.5% of IP addresses, of hits that he sees from Comcast have IPv6 available. 84% is the deployment rate. The next one is AT&T. 82.8% of AT&T customers have IPv6 or capable of IPv6. Celco, I think, is Verizon Mobile.
Verizon, yeah.
Yep, and it's 94.6%. Like, yeah, IPv6 is basically deployed among the major networks. T-Mobile, Charter, UUNet is Verizon Wireline. It's way down at 33%. They started deploying about 3 years ago, and they got pretty high. They got to 20% deployment very rapidly, and then they found a bug in their CPE. So they rolled it all back, but they've started redeploying now, and so they're up to 33%. And it's a pretty good curve. And if you're really excited about your network or somebody that you're, the network that you're, where you are at home or at work, you can click on any of these ASNs, and it'll show you the rate of growth of that network as well. We've got a bunch of Time Warner Cable networks here. You've got to go all the way down to Frontier before you get somebody who's under, I mentioned Verizon Wireline, but you've got to go all the way down to Frontier to get to somebody who's basically not using V6. That's fairly small, and they've, of course, just been bought by Verizon, so I'm expecting that to change. Yeah, I think they remerged. So I think what happened, if somebody knows better, correct me, but I think what happened is, yeah, Frontier bought all of Verizon's DSL subs, and then tried, but not their IP addresses, and had to renumber into all their IPv4 addresses. And then as of 6 months ago-ish, Verizon announced they're buying all of Frontier back in, so you can roll it back in. Yes, no?
Yeah,
Okay.
back in September.
Yeah.
Yeah, that's correct.
Yeah.
I work at Verizon.
Oh, good. Okay, there we go.
Yeah, we're buying them back.
Good luck.
Deal in place in like 12 to 18 months, so it's not closed yet.
Right.
Yeah, we're working on it.
Did you get the Starlink?
What's that? What? Starlink.
81%.
Yeah, that's, way down here. So, not bad.
I'm actually surprised they're that big.
All the endpoints
Yeah.
are V6.
And then, so, yeah, and there's a couple here that aren't that have nothing. The CenturyLink Quest, yeah, still, okay, still backwards there. CableNet, Suddenlink, CableNet's only 27%, Suddenlink's, below 1, Cable One, Mediacom. You got to go pretty low in the,
09 is not the primary ASM for CenturyLink. They have another one.
oh, right. So there's different networks that they're not running this with the same equipment,
I
yeah.
have the CenturyLink in Arizona. I can enable 6 RD, then I will have
Yeah.
V6 IP.
Yeah,
Well, I think the lowest one is CenturyLink, right?
yep,
Yeah, no surprise there. What's funny about that is that the data doesn't say that, but most of that CenturyLink is in Bark, so that's actually Sprint's old wired network.
right. Oh, really? Huh.
Yeah, because it was spun off to Embark when they merged with Nextel, and then CenturyLink bought all of Embark.
I'm curious if the CenturyLink US legacy Quest is legacy DS circuits.
So for anybody who's
It is, yeah.
I'm gonna just sort of summarize the conversation that we're having. For anybody who's watching the video, conversations about which networks own which networks and how they're managed differently. There's one other that I think is kind of interesting. From my understanding, Google Fiber actually, they say their network supports IPv6 100%, but CPE doesn't necessarily. So people bring their own routers and don't turn on V6 automatically. Yeah. Oh, sorry, customer premise equipment. So, and I'm using it a little bit loosely because it might mean your Wi-Fi router, it might mean your modem or whatever, and so it can refer both ways. In Google's case, I'm talking about the Wi-Fi router because I think all of the hardware, the physical equipment actually does support V6. Yeah.
One of the things I noticed on my home network that supports IPv6 is that the IP addresses change frequently. Like, is there, like, which makes it sort of hard to stand up an infrastructure on IPv6?
I would like to talk about addresses changing what to do. I'd like to hold on for a couple minutes because I do have some stuff where I can talk about how that works. Thanks. Because there's one more measurement that I wanted to show. This is NIST showing US government sites, which I thought, based on my last time here, oh, there are some government contractors in the room, so maybe you're interested in how the government's doing. The red line is DNS servers, the blue line is web servers, the green line is mail servers. It's probably not astonishing that nearly 100% of name servers are dual stack capable, right? Nearly 100% are running IPv6. Web servers, we are right around 50%. That's that might be surprising to some folks. It's not that hard to deploy IPv6 on a web server. If it's a vanilla base server, pretty straightforward and simple. It's the sort of the rest of the infrastructure, and again, I want to come back and talk about a lot of that. Mail, I don't know that mail's hard per se, but a lot of people don't trust the anti-spam tools in V6, and part of the reasoning there is in IPv4, you get spam from a server at one IP address, you block that IP address. In IPv6, do you block one address? Do you block 170 billion addresses? Do you block, how many addresses do you block? /48 potentially, and I'm going to talk about what a /48 is.
Now, I would have expected some of these to be higher because there was a mandate.
Good, I'm glad I got things in the right order here. Yes, there are some mandates by the US government to itself to deploy IPv6. The first one was, I think, 2008, 2010. Didn't have a whole lot of effect, right? Another one a couple of years ago saying we are really pushing out IPv6. We're pushing at OMB first, and then the DoD sort of signed on and said, yeah, we're doing that too. And the goal was that we're going to have IPv6 only by 20% of systems are going to be running IPv6 only by 2023, 50% by 2024, and 80% IPv6 only this year. Asterisk, IPv6 only means ideally IPv6 only on the device. There may still be translation somewhere allowing access to the rest of the IPv4 internet. How's this going?
Not well.
No, not well. Not making those numbers, right?
A lot of the software,
Mhm.
especially by contractors, are only IPv4.
Why am I seeing people looking guilty right now? I'm sorry.
Well, I found a really fun vulnerability in several of them, and
Yeah.
I've actually had conversations with different vendors.
Yeah, that's one of your hobbies is finding vulnerabilities in software. Yes, I know.
In IPv6.
Yes, and specifically in IPv6. I also found it interesting that the Army CIO put out, specifically, obviously for the Army, some new guidance about how to deploy IPv6 and new orders. And he said, IPv6, for anything newly deployed, IPv6 has to be on when you plug it in. Like it has to, or I suppose you plug it in, then you put IPv6 on it, like it's part of your boot up process. But enable IPv6 first before you even put it into production, because what a lot of things have been happening under previous mandates was people would say, okay, device supports IPv6. I'm not turning it on, but it supports IPv6, and so no changes happened. So that's interesting. It's been argued to me many times that this OMB memo was more useful and made more progress than the previous version because it came out from the Council of CIOs, and so there was the agencies themselves said, we want to force ourselves to do this, so we're going to put a memo saying we must do this. And it sounds like there's been momentum, but not exactly, okay, good, yep. So there's been momentum, but not exactly, haven't quite accomplished these goals.
When they actually put the OMB, at the end of the year, they have to actually provide all the status. We didn't have that prior to
Right.
2023.
So there are reporting requirements too on both of these saying, show me what's not supporting v6 and why. I'm a little bit concerned that, that there may not be the manpower by the end of the year in various agencies to get all that done. We'll see. Yeah.
Does this memo apply only at the edge, or does it apply within the networks as well?
It says
Supposed to
all
be a
blanket. It says all devices.
And I guess my follow-up question to that is, like, where's the advantage for having it internally versus having it just at the edges?
That's a great question. And so some of the drivers for, and this is just a blog series at Aaron that describes some of the drivers for why you would want IPv6 in general. Let me talk about these a bit, and I'm going to talk about some edge versus internal in some depth, both now and in a few minutes. So good. I love the great questions. Also loving the engagement. Makes it feel lively. Enjoying it. So a couple of things. I actually wrote a couple of these blogs. I hope I remember which ones. So the first title is Time is Money in E-commerce. It turns out that a lot of different companies that we've heard of have done speed measurements, comparing, we're worried about IPv6, rolling out IPv6, because what if it's slower than IPv4 and it's a worse user experience? So they measured. I'm talking about Facebook and LinkedIn, like networks we've heard of. Apple did publish some measurements, and it turns out that on average, IPv6 was slightly faster than IPv4. And everybody kind of scratched their heads and said, well, how could it be faster? At the very least, it's got more bits to process, right? You're shoving a packet through a network. Some device has to inspect those bits and go, where do I send this packet next? And it's more bits. It should at least be a little bit slower. So I went back and I did some analysis, and I looked at network by network, which networks were exactly the same, IPv4 and IPv6, which were slower in IPv6. And I don't think there were any, realistically, that were slower. I mean, there were a couple of networks that were slower in IPv6 than IPv4, but they were in really far distant countries, so they may not have had the same transit. So I looked at mostly US companies, and what I found was companies that had deployed, that were, in particular mobile carriers, that were v6 only to the handset, instead of dual stack on the handset, were slightly slower over IPv4 than IPv6. And the reason is, this is an Android phone. Apple said, every device, every app that goes into the Apple Store must, when you're submitting it, you have to check a box that says, I tested this in an IPv6 only environment. And that includes a NAT64, so a translated environment. Android, Google said, we don't have that kind of control over our app developers. So they put a software shim in Android that if you have an app that's trying to use IPv4, it'll translate it to IPv6, send it across the network, and then translate it back to IPv4. 464 XLAT is the name of that technology. But I realized that what's happening is that shim is in software. So they're doing NAT in software rather than in hardware, and it adds a couple of milliseconds of latency for every packet coming out of an Android phone. And that's why IPv6 is just a little bit faster than IPv4, in some cases for some devices, and then so for overall on average because it's large deployments. Now, it's a couple of milliseconds. It doesn't really matter in most cases. If you are an e-commerce provider, if you are or a social media site, that kind of latency affects performance in a way that you can measure in terms of dollars. You can say, users stay on my platform longer if it's just a few milliseconds faster. People buy more stuff if it's a few milliseconds faster. And so it actually matters to those companies for money. Yeah, my favorite, second title there, my favorite, sell your IPv4 addresses. That's a good reason to deploy IPv6. There's some detail in there. I don't remember all the details on the IPv6 only enterprise. We are getting to a point where if half of Google's traffic is over IPv6, let me stop and caveat that. I just said half of their traffic. That's not quite true. Half of their hits are over IPv6. But if you're streaming YouTube to your television, there's a good chance that stream is over IPv4. If you're streaming to your phone, it'll be over IPv6. But your TV is one of those consumer electronics devices that they haven't bothered putting IPv6 into. So it's not, if you actually look at traffic flows in terms of number of bits flowing through the network, it's not quite half. But number of hits is just over. So if half of contacts are over IPv6, then we're starting to see a reason why an enterprise might care. I'm going to talk about that a little bit more. And boy, internet versus intranets, it's a really good one. If you are connecting your network to another network, you'd really like to make sure you have unique addresses. And that kind of helps. Network address translation, where you've got your private addresses inside the network, and you're translating it to a public IPv4 address on the edge of your firewall or router or some other device. That kind of works until you're trying to put those networks behind the NATs together. And at that point, you've got a high likelihood of overlap. Really a pain with M&A, something that I have dealt with a few times when I was working for a government contractor. So, yeah.
I've got a fifth one.
A fifth one.
Congestion control.
Congestion control. Okay, how? Why?
So congestion control is end-to-end.
Mm-hmm.
But when you have NATs more than one NAT, essentially you're not able to validate the congestion controls from end to end. With IPv6, it's end-to-end congestion control management, which has been really cool from a testing standpoint.
So when you start stacking NATs, congestion control is a good example. There are other things that break too, and this is something that lots of other countries are used to saying. Well, you've got a home user, they've got a Wi-Fi router in the home, and that's doing NAT, but it's doing NAT to another private address, and the ISP has a carrier-grade NAT. And so there's a lot of things in there that start to go wrong when you start seeing NAT 444. And those are, actually did some testing coming up on 10 years ago. A little more than 10 years ago. Wrote an RFC on it, on effects, application effects of carrier-grade NAT. There's a couple of things that, for instance, here's an example. Another thing that doesn't work well through multiple layers of NAT is you're trying to set up a gaming session. You've got two users in homes. You're trying to reach each other. You've got multiple layers of NAT. Well, so you maybe contact an external server, and the server says, oh, you want to play with that guy? Here's his IP address. Go establish a connection. Well, that means that that guy has to have a way for you to get in, and if you're doing a fully stateful NAT, it's not going to allow that. So you have to start tweaking it. If you put both users behind a carrier-grade NAT, how is that even going to get through? How are you going to know that you can punch a hole in that NAT to get forwarded to the other NAT, to get forwarded to it? It gets very complicated and challenging. I'm going to talk more about that in a little bit. But the But first I'm going to talk about some of the fundamentals. Like, let's talk about IPv6 rather than sort of the market of why people are using IPv6. So we established that in the early 90s, people went, hey, this internet thing is looking pretty promising. It's kind of growing. And if it keeps growing like this, we're going to run out of IPv4 addresses. IPv4, obviously, very solid protocol, no complaints. In 1978, when Vint Cerf and Bob Kahn wrote the first draft of the Internet Protocol, they said, all right, we're going to use 32 bits for the address field. 32 seems like a good round number in binary, and that gives us 4.3 billion possible addresses. It's 1978. 4 billion addresses, 4 billion devices on the internet seemed like more than was conceivable. How many computers existed in 1978? And then 1979, 1980, sure, you're starting to see some home computers and some BBSs and dial-up, but it's still, the internet as we know it is still a research network. So it wasn't until, then we saw the PC boom of the 80s, early 90s, people said, uh-oh, this is going public, we're going to run out of addresses, we need to come up with a new protocol. So they tossed around a whole bunch of different ideas for how to structure it, and they ended up, and sort of the end consensus was 128 bits. So it's 340 trillion, 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 or 340 billion, 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 or 340 undecillion. Somebody did the analogy once, if you were to fill the Great Lakes with peanut M&Ms, you could give every M&M a unique IPv6 address, and you'd be fine. There's a wonderful XKCD from years ago that is nanobots eating the Earth. And so somebody back in space goes, oh my gosh, the nanobots finally stopped, and a third of half of the Earth has been eaten away. What happened? Oh, each nanobot had a unique IPv6 address, and they finally ran out of IPv6 addresses. So there's a lot, but then you start to run into problems. Yeah, I get that all the time. You start to run into problems. How are you going to write this address, right? We came up with dotted quad in IPv4, 192.0.2.1, perfectly happy. But if you're trying to do that kind of dotted decimal notation where each segment of the address is 0 to 255, that's a lot of digits that you have to write out. And so that's a little overwhelming. It's a little heavy there. So they decided to use hexadecimal. That's sort of how we got there. And then somebody said, well, but we're going to still use dots, right? It's just hex and dots. And somebody said, well, but we might want to be able to embed the IPv4 address in the IPv6 address someplace. And we need to be able to show that the IPv4 part is the dotted quad that we're used to, and the IPv6 is something else. And that's how we ended up with colons. I don't love the fact that I have to use extra keystrokes to type addresses, so I try to avoid it. There is a 10-key style keypad that you can, that plugs into USB that you can get. That actually, so it's like a number pad, but it adds in the hex letters and colons and slashes. So if you need to type a lot of addresses, you can buy that, the IPv6 Buddy. Little ridiculous there. Okay, format of the address. Many of you have seen this before, even if you haven't thought about it before. 2001:0DB8 is the documentation prefix. There's actually a new RFC a few weeks ago, I think, approving an additional prefix for documentation. So 2001:DB8 1 2 3 4 5 6 7 8 9 0 A B C D F F F whatever 0 0. So the way I have it, I'm going to use my right hand here. The way I have this written on top is sort of the full-length version. It's still a little overwhelming. It's still a lot of digits. So there's a couple of rules that you can use to compress addresses, to make them shorter. By the way, it doesn't really matter whether you use lowercase or capital. Both are acceptable by RFC. The general convention is now to use lowercase so that you don't mix up letters and numbers. It's a little bit easier to distinguish, but it's fine. If you have to write an address parser, think about the fact that you may need to be able to parse capitals and lowercase. If you've got to do a regex, for instance, that's something to just bear in mind. Could be either way. The hard thing when doing a parser or something like that is that you can drop the leading 0 of any chomp. It's not a byte. It's bigger than a byte. So you can drop the first 0. You can't drop the later zeros. You can't drop. So if we've got 90AB, you can't drop it in the middle because you wouldn't know whether the dropped digit was in the beginning, the middle, or the end. Same thing if it were 5670. You can't drop the trailing 0. you need to know which zeros you're going to fill back in. You can, if you have a whole bunch of zeros in a row, you can say colon colon instead of a string of zeros. But you can only do that once, because if you do that twice in an address, then you don't know how many zeros to fill in each space. So it's a little bit goofy, and, but it does really help when you sort of start to get used to it, and you start to be able to say, okay, I'm remembering this now. On this particular slide, I show the first set of digits in orange and the rest in white, just to sort of say this is a halfway point. The default assignment in IPv6 for a LAN segment is a /64. So all the first half of the bits, all 64 bits in the address, which is 4.3 billion to the 4.3 billion, I think. The first half of those bits is the network number, and so you can use all of the rest of the bits, all the rest of those digits as your host bits. You can put a lot of devices in a 1/64, a lot. Probably don't. Another new RFC, this is last year, says that if you are deploying a server, you can give a /64 to a server. And the real reason for that is if you're running containers in there and you want to give each container its own v6 address. Did you have a question before I go to you?
Just quickly, so if you have like, if you were gonna like get if you have your own network, then the last half is everything in your network.
Right.
And then first half is
the first
world know where your network is.
The first half is the network address, and the second half is the host address. Yes. And I'm going to do that a little bit more in there because this is the hardest part. Just getting used to the numbers is the hardest part of IPv6. Yeah.
Just for context, 1/64 is 2 to the 32 times bigger than 1 IPv4 internet, right?
Yes.
Okay.
I believe that's correct. I believe that's the way the math works, is that 2 to the 32, yes. So it's 4.3 billion times 4.3 billion, no, yeah. 4.3 billion to the, 4.3 billion internets. It's an internet full of internets. It's a stinking lot of addresses. And there were reasons for doing that. Some of them were better than others. And I'm sort of going to go into this a little bit. So actually, let me skip forward and I'll come back. I'll do it on the slide. Okay, now I've got it between orange and blue. Exactly what you said. The first half of these digits, the first, and it's 4 sections, 4 chomps between the colons, right? So I can go 1, 2, 3, 4. I know that's a /64. By the way, it works out really nicely. I know that 4 of those is a 64. I know that 3 sections is a 48. I know that 2 sections there is a 32, and 1 is a /16. It's, this is sort of just the way binary or hexadecimal works. It's convenient. And when you start to get used to that, yes, it looks like classful addressing. It looks an awful lot like class A, B, C, like from what you might remember from a class, decades ago. But we've got so many addresses to play with, and we can get finer tuned here. And you can see I've got the 2001 :DB8. I've taken off that first 0 because it's just easier to write. 1, 2, 3, 4, 5, 6, 7, 8, :/64. In this case, I've taken some host bits. I've got some zeros filled in the middle there. Makes it a little bit easier for me to be able to substitute those zeros with 2 colons. And a /128 is a single host address. This right here, and I keep trying to think about how do I make this simpler. It's not that this is hard. It's not that it's especially complicated. It's just so different than what we're used to thinking about in IPv4 that wrapping your head around, wait, a 64, I've seen a 32 before. /32 is a single address in IPv4. So a /32, that little bit of a section of an IPv6 address is an entire address in IPv4. And so getting used to, wait, is a 46 bigger or smaller than a 48? That's kind of the hard part, but it's really just getting used to it. So don't let it freak you out. It's really just getting used to it. I think that IPv6 is in some ways easier than IPv4 because if I've got, so here's a /64, 2001 :DB8 :1234 :5678. That's a /60. I've got the full address there. So up to that point it's a /64. I know that flip a digit, and it's the next /64. Flip the next digit from 8 to 9 to A, it's the next /64. I can see just by looking at these bits that this device is in the same /64 network as this device. That doesn't sound like a really big deal until you think about, wait, so in IPv4, 192.168.214.179, is .179 in the same subnet as 209? The answer is no, but you got to do real math to get there. You just look at it in IPv6, and it's when you're doing a little bit of subnetting, you start to go, oh man, what a relief. I've got a couple of thoughts about, this is a networking class. I don't want to go too deep on it, but I like, when coming up with a network plan, I like using some significators in those bits. I like to use a building number or a VLAN number or some other indicator to help me with the mnemonics. Because no, you're not going to expect to be able to remember that address. You can remember quad 9, but you can't remember the 22480:8844::. I know Google's quad 8 does have a v6 equivalent. I used to know it off the top of my head, but I can't remember it anymore. So that's the sort of thing I do. You will often see in a 128, you'll often see like all of the bits being 0 and then just a 1 at the end. So you've got a : : 1, : : 2 in a little tiny subnet. It just, again, if you remember, that's that side and this is this side. It makes it a little bit easier. There is.
If you deal with /63, then the number getting harder to.
If you're dealing with 63, yeah. So I like to use even numbers. What I really like is to use nibble boundaries. So I like to use 64, 60, 56, 52, 48, those divisible by 4s, because it makes, and you've got so much space. If you need to go to Aaron and say, I need addresses, you can get a lot of space, and you can waste a lot of space and still be fine. And I know people say, but if we waste space in IPv6, we'll end up with the same problem that we had in IPv4. I did a thought experiment 20 years ago. I said, how could we ever possibly run out of IPv6 addresses? And just like the nanobots experiment or thought experiment, I came up with,
If people keep asking for /29, then it will run out.
you know, okay, /29 is
Allocation in right.
right. But so I'm trying to think how many /29s are there? There are. What's that? There's 5. Well, so a /30 is 4 addresses. So a /29 is 8 addresses in IPv4, which means there are 2 to the 24th. 2 to the 29th number of /29s. How many networks are there on the planet?
First number has to be 2 because.
Well, it has so.
It's not a 2. It's considered program.
So the first number has to be 2 right now because we've only allocated 1/8 of the IPv6 address space for unicast space. So we've got a lot of room to grow. My thought experiment was if every single product, if every single UPC code had a /64 assigned to it, and every single device, every single thing that was ever sold under that UPC code had a unique IP address, it would still take 200 years to run out of v6. Yeah.
Well, the RER system has policies in place for how much they will read out at any one time, which looks at,
Right.
That's part of like what's your usage of what you currently have. Do you get more? So there's sanity at the human level. Is that
Right.
what's dishing out what people ask for?
And I think that's so your comment was if we keep handing out /29s like the default allocation in RIPE, we may eventually be constrained. I'm not terribly concerned, at least in the short term. And as Ed points out, in the back end, there is still an ongoing policy process to figure out, oh, okay, we gave out too many addresses early on. We can see we're coming into a problem, and we can deal with it.
Hey, Cleve?
Yeah.
So, has anyone ever thought about coming up with a base 32 or base 64 encoding the addresses just so they're a lot easier to remember?
I don't think so. I don't think there's ever been any discussion of using other bases than 16. I think that everybody kind of early on went, well, everybody understands base 16. Like hexadecimal is easy, so everybody understands that, so it'll be easy. Trying to go to 32 bits or 64-bit base systems No, I don't think it's ever been discussed. Could it be done? I don't know why not. And yes, you do get some fun things like people, so my next thought was, how many letters are there? And what do those addresses look like? And you do get fun things like people using vanity addresses. Facebook has their prefix plus the host address is FACEB00C, Facebook. Cisco did C1SC0 for Cisco. Dead beef, lots of fun with hex. Saw another hand someplace.
The IPv6 address is actually registered by ANSI so that it doesn't confuse with other naming systems.
Oh, okay. So so there is a reason that's in standards that ANSI has already codified it. Not that you can't change a standard or update a standard, or even use the same addressing scheme but then have a different representation of it. Right, like the emoji. So another thing that sometimes surprises people in IPv6 is that there are multiple addresses on your device, and that's you know, it may seem strange and odd. It is part of how you deal with my address is changing, is you can have multiple global unicast addresses on your device. In this case, I'm showing, oh good, I did ifconfig, not ipconfig. So here's your MAC address. Here's inet6 FE80. That prefix means link local. So you're not going to use that address on the global internet. But that does mean that you can use that to communicate with other devices on that LAN, on that broadcast segment. So you can get to your printer or your router or something else on the segment using just link local. And then here we have a global unicast. Looks awfully familiar. One of the fun things hiding in here, and this is now deprecated, but you still see it in the wild sometimes, is this host address. We got 2001:DB8:100::. 685B:35FF::FE7D:3BBD. That host address looks kind of like that MAC address, doesn't it? The first half of the MAC address is here, and then you've got FFFE, and you've got the second half of the MAC address. It seemed like a really clever idea at the time. Hey, we're using hexadecimal. It's got colons. Let's just shove the MAC address in there. And it was actually part of the idea, part of the reason they decided to add. Originally, they were talking about just a 64-bit address space, and then they said, well, what if we wanted to use the MAC address as the host address? Wouldn't that be brilliant? And so and they said, okay, so we'll just add another 48 bits. Well, but what if there's another hardware address space that's larger than 48 bits? Let's make it 64, just for round numbers. Bits are free. You don't see that anymore. What you mostly see now is privacy addresses. So, you know what, let me get into how you get an address. Yeah?
Yeah, by the way, certain vendors are still using it.
Yeah, that's why you still see it in the wild. I wouldn't expect it on a general purpose internet device, but yeah, some vendors are still doing that.
Every machine has that address, but it's not used by default. It's not default.
Okay, so you may have the address but not use it.
Yeah, but that page, I think one of the bits in the MAC address would be flipped. It's not the same form of MAC address.
I thought it was. So I thought it was. Oh, sorry, you're talking about a specific implementation or the general spec?
In general, that address, one of the bits is flipped.
Interesting. Well, so I knew the FFFE was
6A, it will become something else.
instead of 6A, it would be something else. Okay.
Only change one bit.
Yeah, but that FE80 address never leaves your network anyway, so
Right.
the exposure is.
Right. It is link local. I sort of touched on this. If you're doing an address plan, try to use nibble boundaries if you can, and use like the 64, 60, 56 numbers, and use those because if you have to delegate DNS, especially if you have to delegate reverse DNS, it's going to be a real nuisance to have to delegate multiple reverse zones to do that. Now, different ISPs, residential ISPs, have different sizes that they're allocating by default to your home. So you can take a look and see how much address space they're giving you. Generally, you're probably only going to see 1/64 unless you're doing some clever VLANing and stuff in your network. Yeah.
Verizon provides a 56.
Verizon does a 56. At Time Warner Cable, we decided on a 56, and I kind of had to push for it pretty hard. At the time, we actually defaulted to a /64, so one LAN block of addresses, because some devices, if they got more than that, would just brick. They would just fail. And so we said, okay, we'll give you a 56 if you ask for it, but by default, we'll give you a 64 until we took those devices out. Yeah?
Is what was the acronym you used for the consumer? The
CPE, Customer Premise Equipment, yeah.
Is the net you're assigned matched to the CPE? Do you get the same one every time?
So that was the same question over here. And so the answer is usually, like what we're seeing in the wild. So when we first did deployments, it was really, really hard to do disaggregation. If I moved a neighborhood from one CMTS to an adjacent CMTS, I was going to have to renumber that customer. But I didn't have a way to do it dynamically. I couldn't do withdrawals of the routes within the network. It is still using, in many networks at least, DHCP or something like DHCP. I'm going to come back to more about the differences in DHCP. So it is still dynamic, much like your IPv4 address. You're usually getting the same IPv4 address over and over and over for months. And every year, or every 6 months, something, you may just hit the other DHCP server, the backup server, and get a different address. Basically the same in IPv6 is what I'm seeing is usually you're going to renew your DHCP lease and get the same block, but you can't rely on that.
This is a question. This leads into a question I had earlier. So I have Verizon at home, but I use their
router?
Not their router, but their modem,
Mm-hmm.
and it plugs into my router, and my router specifically probably asks for it's DHCP and it gets a V4 external address. If I configured it to ask for a V6, it would get a V6 external address?
I think so.
Yes. So do you have Fios?
I have Fios, yeah.
Okay,
Yeah.
so their modem is really just a media converter box.
Yeah.
That converts from fiber to Ethernet. When you plug in your box, so I run OpenSense, and I have mine configured to pull.
PWRT.
Okay, so
Yep.
you just need to configure your WAN connection to pull IPv6.
And if I send IPv4 out, Verizon Magic will make sure that it gets where it needs to go.
Unlike a DDWRT, yeah, you just need to go into the UI, and I don't know what the command is or what the click is, but and say turn on IPv6, and it will probably from there automatically say do a DHCP discovery, just like in IPv4. It'll say, hey, is there anybody out there who can give me a V6 address? And they will, and Verizon will relay that to their server and give you V6.
Get Google at 51% then.
That'd be great.
The dirty secret with that, most of that stuff is most modern devices when you do a DNS lookup, you get both addresses.
Yes.
And then it looks at your stack, and if you have a V4, if you have a V6 path, it'll prefer that. If you don't have it configured, it throws it away.
Thank you. I actually forgot to put a slide in about happy eyeballs. And I was thinking about that on the drive here this morning, that I wanted to mention it. So as we were doing early scale deployments, and I'm talking Time Warner Cable and Comcast and AT&T and Google and Yahoo, back when Yahoo was big, we were all talking about how are we going to do this and make sure that we're not breaking anything. And some guys at Cisco, in particular, were worried that what if a device just has a bad implementation of V6? What if something goes wrong somewhere in the network? And they came up with an algorithm, and they called it happy eyeballs. We want the eyeball users to get the best experience either way. And so the original algorithm said, if you've got both, if you're running dual stack, do your DNS lookup, get both answers. Whichever answer comes first, use that address, use that family. So if your A record comes back, query comes back first, use IPv4. If your quad A response comes back first, use IPv6. After a little time, they updated that and said, let's give IPv6 a little bit of a head start. I think Apple started that first independently and reported back and said, yeah, it's working great. So they actually fire off a V6 DNS query first, and then if it doesn't come back within some number of milliseconds, 100 milliseconds, something like that, then they'll fire off the V4 request. And if the V6 response comes back while waiting for V4, they'll still use V6. They're just waiting for they'll just cache the IPv4 response. And by doing that, it's really great because it means that if something breaks, if you're dual stacked and something breaks somewhere in routing, somewhere on the internet, then you still have a backup path. You still have a way to get the internet to work on your device. The downside is the users don't call. You don't get the trouble reports. If something breaks, you may not know. And so one of my big tips for running IPv6 on a server in particular is instead of just monitoring is the server up or down, you need to monitor, is it up on IPv4? Is it up on IPv6? And you may also want to monitor, is it up in DNS? So there's more monitoring to pay attention to. And then you have to decide, is that an outage or is that a degraded scenario? That's local policy. Yeah?
Will you cover RA and DHCP v6?
Acquiring an address. Yeah, exactly. So you plug in a device into your network. Plug in, how old am I? So you connect the device to a network. First, we're going to start with with link local. So device is on a network, and this device says, hello, this device starts, we're going left to right. This device says, hello, all nodes multicast address. FF02::1 is all nodes on my link, on the local link. I have this link local address. What is the MAC address of this other device? There's some communication going on. So this is like doing ARP, except as neighbor discovery. So it's different, it's using multicast. I've heard somebody allege that the reason we're using multicast instead of broadcast is that one of the primary authors of this had just written his PhD thesis on multicast, and therefore, I don't know if that's true. I've also heard it said that this is actually better in low power networks because you're only addressing devices that are listening on that multicast address. So, doing discovery, I have this link local address. Hi, that link local address. I am this global unique address. So LLA, link local, GUA, global unique. And here's my MAC address. Looks a lot like it, and then you can build a hardware table. So now you can do your forwarding. If I need to reach something locally at layer 2, then I've got the MAC address, and I can do the layer 2 discovery. The reason that's interesting isn't. The reason that I wanted to show you that is so we can get to, there's three ways for a device to get an IP address, an IPv6 address assigned to it. The first way is you go into the network config file and you manually add an address there. Right, and that's the least preferred, but if that's the way you want to do it, your network, your device, do it. The second way is called SLAC, Stateless Address Auto Configuration. Oh, it's even written there, good. Stateless Address Auto Configuration, SLAC. And SLAC is not terribly confusing, really. Same protocol, still using the neighbor discovery protocol, but it says, hello, all nodes. I have this address. Oh, sorry. I'm starting at the router this time. The router says, I have a /64 assigned to me. I've gotten it through DHCP v6, or I've gotten it through somebody manually configuring the /64. And it announces to the entire LAN, this /64 is available for use. And if you need to reach something that's not link local, I'm the router. Send it to me. This device says, oh, great to hear that that /64 is available. I'm going to pick a random number out of that block and assign it to myself. Hello, everybody. I'm now this address. The reason you need to say, hey, everybody, I have this address is just duplicate address detection. Like, let's make sure that even though it's a really, really big number of possibilities in there, there's a teeny tiny chance that you could get an address that overlaps. So you make sure that everybody knows that that's who you are. Dead simple. A couple of things that are slightly annoying about it. I'm going to talk a little bit more about security, making sure we're okay on time.
We'll stay.
One thing so I love this. It's super easy. It's the only way that Android will work. Android doesn't support DHCP v6. It took a surprisingly long time to add support for DNS servers. Like, hey, here's an address block you can use, and here's a resolver you can use. Before you had that, it was really hard to do anything with this. But if you're trying to log, if you're out, you've got a firewall or security device out there, and you're trying to log which device is using which IP address, you no longer have your DHCP server logging that for you. That said, if you're using DHCP to assign addresses and log everybody who's connected to your network, you're not protecting yourself against somebody connecting to your network and manually assigning an address. So you're no worse off, really, somebody randomly assigning themselves an address than you were in DHCP v4, but you might want to pull some logs from here. Just whenever there's a new address assignment, log that to a syslog server someplace else, just so you've got that tracking ability. Otherwise, smooth, easy, but it's not like DHCP. There are two flavors of DHCP v6. You might see it documented as IANA and IAPD, but I never call them that. That's just what the official terms are. So there's individual address, network association, what's it called, and prefix delegation. The difference there is, hey, I need an IP address, give me an IP address, versus, hey, I need a /64 or a /56 or a /48, give me a block. And that's the only difference. The packets are formatted the same, the responses are formatted the same, and then you get the information. There's a little bit of sort of routing device magic that happens on the router to say, I've learned this /56, how do I assign, if I've got multiple interfaces, how do I assign those downstream? It's sort of device-specific magic and probably not particularly relevant. This is great because now you know, it's great because if you assign a prefix here, you know it's dynamic, you can move things around and it'll just come right back up. The downside is you still don't have the logging of the individual hosts. Now, if you're a residential ISP, who cares? If you're running a government network, you might care an awful lot. Yeah, good. Security. Some people say, and I took out the slide that says this, IPv6 is more secure than IPv4 because IPsec is mandated. Well, I don't know how many people are using IPsec on a regular basis. Sure, it's mandated, but then it was backported to IPv4, and so you can use IPsec in either address family or not, and so that's baloney. And my general statement on security in v6 is there's a couple of things that are a little bit different. It's not more secure or less secure. It's just a little bit differently secure in some ways that'll sort of become obvious. Big one is a lot of people will tell me, I can't use v6. I don't want globally unique addresses. I need my NAT for security. A NAT is not a firewall. Okay, good. I'm glad to hear laughter. A NAT is not a firewall. If you are completely offline, if you're doing nothing, then, and you've got a stateful NAT on the edge of your network, yeah, a packet coming in isn't going to reach you. But the way most NATs are deployed, especially because of that gaming scenario, is, oh gosh, okay. So I've got a source packet with a private address here, 192.168, going to a web server, 192.0.2.80 on port 443. That goes to the NAT box, which does the translation to the destination stays the same. Its outside address, though, becomes the source port, the source address, and then it goes to the network. You go to a mediation server, a game server. In many cases, there are workarounds now, but phone service, like using voice over IP, this was a huge issue in the early days of VoIP. If you're trying to reach that device over there, this server would say, B, go talk on that address, and you've got to your NAT. The trouble is, if NAT was a firewall, then B would send that packet over there, and the packet would drop because that NAT wouldn't know that source address. It knows that source address. It knows if it was setting up a state table using source address, source port, destination address, destination port, and protocol, TCP, UDP, whatever. If you're using all 5, yes, that's a stateful firewall. If you're using all 5 and you're expecting a packet from a host that you don't know on the internet, you don't have that information. So in practice, most people are actually doing a full cone. So you send the packet outbound, and the NAT says, okay, I now know that anything headed to this port on my address, I'm just going to forward it down here. Which means, as soon as you have any communication to anything on the internet, any packet coming inbound to that address and port is going to be forwarded to you. That doesn't sound like a firewall to me. That sounds like a forwarding table. And so, yeah, so that, and this is what happens in most cases. As I said, once you have any connection outbound, it opens that table up so that anybody can come in. Does your device, does your laptop sitting on your Wi-Fi at home ever not have an outbound connection anymore? It's always chatting. It's always doing something, right? So those tables are just staying open. So what does that mean? You need a firewall. I mean, that probably isn't a surprise to most people that you ought to have a firewall on any given network. Obviously, security best practices have significantly evolved, and firewalls alone are, the crunchy exterior, soft interior is no longer the best model. Take a security class. A lot of people will say, wow, it's more secure because you can't do host scanning. It's just too much address space. You can't possibly ping the whole space. There's an RFC on this. It turns out, so that's how many addresses are in a 64. But there are some likely addresses, like ::1::2, yeah. ::80, a lot of people use 80 for their web server, or 443. For some reason, people will still use 80 as their address, even though they're expecting HTTPS. And then a couple of other things that you might expect: :1:1, beef or other fun words. This is an embedded IPv4 address, and so you might expect that. Or, remember I talked about that using the MAC address in the, as the host bits in the host address? So if you can say, well, I know the organizational unit identifier, yeah, that's what OUI stands for. If I know the hardware manufacturer of most network interface cards, then I only have to scan this many possible addresses, the X's, that many possible addresses in order to find likely hosts. It's harder, but it's not impossible to scan likely addresses in IPv6. And then, of course, there's DNS. There's other ways to discover where a host's actually coming from.
Yeah, the interesting part is that's the fastest way of scanning any IPv6 network, that particular framework. And there are people doing just those, but not actually complex scanning.
Yeah, every time I talk to Joe, I get scared. So basic mitigations for host scanning, sort of the stuff you would expect, right? Have a firewall, have an intrusion detection and prevention system. Generally, configure that firewall to block ICMPv6 requests. Just block ping, but don't block. There's several different ICMPv6 message types: echo request, echo reply. That's ping, right? Don't block the packet too big request, because if you do that, then you're going to break your connectivity. So fragmentation is in IPv6 is only permitted at the endpoints. The idea is that it will be faster if there's some place where the packet size, the MTU out on the network, goes from really big packet size to a teeny tiny packet size. It makes more sense to drop that packet and send a message back saying that packet is too big, make it smaller. If you are dropping all ICMP, then you're not going to get that message, and some connectivity might fail. Makes it really, really hard to troubleshoot when that happens. Yeah, you can do policing to prevent floods. So you can say, if you have a sophisticated enough device, I won't take more than 10 packet too bigs per second or something, just to protect that. You can also ignore what I said earlier, but I like to put building numbers or VLAN numbers into the address space. That's a mitigator. And you can randomly change your addresses. That's a pretty good one, and it is sort of the default now. I think the default timer is 24 hours. So your laptop, your device, is probably changing its IP address every 24 hours by default. And that's generally configurable. I don't remember where, but it's generally a configurable bit. So you can say, I want to make it harder to track me by IP address as I go around the web, so I'm going to change my address every 5 minutes. It does mean long-lasting traffic. You have to do, make before break kinds of connections. Not impossible. Oh yeah, this is the slide I said before, IPsec. Yeah. Yeah?
Just a quick question. So the slide you showed 2 ago with port 8,
Yep.
but 443 isn't on that.
You're right. So I tried to say that out loud. I didn't say it well. So yeah, ::80 is a common address. ::443 is probably also common. You might find ::25 for a mail server. It's a mnemonic. It's a way to remember those things. But I just didn't list every possible.
I'm just wondering if this is literally what they.
This is not exhaustive, no. But it's a sample of the kinds of easy things. Like there are many other words than beef that you might find.
Yeah, I also do that, but I put a random 4 digits right after
Yep.
the /64.
Yeah, so you can.
64 to 80, I have 4 random numbers.
That's pretty good. So instead of doing 2001:DB8 F001:1/64, you could do ::1 some random 4 digits ::64, and then all the hosts in there it'll be harder to scan because it's some random number. This is also not this is not my major fear in IPv6, nor is IPsec. This one scares me a little bit. There is a vulnerability, sort of, and again, I don't think this isn't the one that's scared. Again, I don't think this is really any worse than an IPv4. So there's, what's that?
It's no worse than ARP.
Yeah, it's no worse than ARP. So you can have a device say, hey, I'm a router. Somebody plugs in a device, says, hey, I'm a router, route all traffic to me. You can do that in IPv6 over neighbor discovery. You can do it with DHCP or anything in IPv4. Yeah?
Well, it's neighbor poisoning, that's what the term is.
Yep.
It's not really that major.
Right.
It's not the same concept.
There's, yeah, so I kind of go through this, and you can have a device that's, gets compromised and just sends out a whole bunch of neighbor discovery requests before waiting for receipt, and you can exhaust that neighbor table. Much like, the neighbor table is a lot like the ARP table. Okay, so you get a compromised box, it can compromise your local network. It's possible to do this remotely, so you probably want to block that. Don't let people do neighbor discovery from outside your network. Pretty standard there. I talked about this one earlier, using, oh yeah, there it is. Okay, so some people, so log your device associations when they come on the network. New RFC, actually I added this after I did this presentation, it was the last Nano, not the one last week, but the one in November. And somebody pointed out, okay, now there's an RFC that allows you to give a prefix, a /64, to a server. Syslog, SNP, yeah, log your neighbor discovery tables. Use 802.1x or admission control. Use something so you know which devices are connecting to your network, and don't use IP addresses as identity. They are not. We did that one. Ping pong attack, just like the name of this one. If you have two devices directly connected to each other and they're on the same /64, you can ping, bless you. You could ping any address that's on that /64, and this device will say, oh, it's not my address, so I'm going to send it out on the network. And that device will say, it's not mine, I'm going to send that packet back out on the network. And they'll just forward it back and forth between each other. Best practice, if you've got point-to-point connections like that, is allocate the 64, but configure them as individual /127s. So keep it so that it's a /127 configured network, so they won't forward. They'll just say, I don't have a route to that.
TTL will still take effect in it, right?
It will, yeah. So you can only do, it's still TTL of 30, so you can still, so you'll still drop it eventually, but it's an amplification attack, right? One ping gets 30 packets, probably fewer because you've already taken a couple hops to get there. Yeah?
Depending on the size of the network, spanning tree.
Let me think about that for a minute. So, yes. Yeah, I was using the example of point-to-point here, but yeah, in a spanning tree network, similar, it's going to be the same thing. It's still going to be it's a layer 2 network, and you're going to want to have mitigations against external devices doing discovery. But otherwise, I think it's exactly the same, right?
It's about the same as a broadcast storm, but
yeah.
The one thing you can basically do, once again, point-to-point connection, or you can just simply say, if you see this and you've seen it now twice, kill immediately.
Right. And yeah, the favorite, yes, you can, yeah, /127, or same as with the previous thing, do some rate limiting. Yep. Yeah. And you don't have to do that on the local network. If you've got a WAN, if you've got an enterprise network, if you've got a larger network, you could do that at your network perimeter, where you probably have a more sophisticated security device anyway. We talked about all of those, rate limiting, yes?
So, in Ubuntu or something like that, how would I set a static IPv6 address so I could have a web page? When I look on my home machine right now, I currently have 6 IPv6 addresses.
Mm-hmm.
So I just need to set an additional one, or if I do set a static one, would that remove all the other IPv6 addresses?
It will not remove all the other IP addresses. So if you want to statically configure an address on your Linux box, so it can be a web server or whatever kind of server, no, it's exactly the same as configuring. If you're manually configuring, it's exactly the same as configuring IPv4. You need to figure out what network prefix you have, what your network range is, pick an address, and then put it in whatever the right config file is. And I'm being a little vague because I think it's different between BSD and Linux.
We don't talk about BSD.
Right, no, it's not.
What's that? Like, it's one of those things where, like, if I was going back in time, I would now choose Debian.
Yep.
That's a different story.
So, you're right.
Find your service to the port on whatever address you want.
Good point, yes. I mean, but again, just like you would in IPv4, right?
I was gonna say, so I haven't mucked with IPv6. In fact, in most instances, I rip it out any chance I get. Because it causes other problems, especially in Windows, or at least it used to. I don't know if it still does, but we're not talking about Windows here. Does IPv6 DHCP v6 support reservations?
Yes.
Okay.
Again,
Just like IPv.
again, exactly the same as in IPv4. You, on your DHCP servers, you can reserve addresses for individual devices. There is a nuance here that there are, I think the DHCP unique identifier, I think there are 3 ways to create that in DHCPv6.
Okay.
And so you might need to know what kind of identifier your host is sending when it's sending the DHCP discovery request.
Okay.
That's probably an easy, check the logs kind of
Well, no, that's
point,
fine.
but
It's
yep.
going on what he said. Like, I stopped trying to assign
Right.
static IPs long ago.
Right.
Because I hated keeping track of it.
Because then you've got to go. Yeah,
So I just roll. I have my scope.
you've got your server. Yep.
And then I have what's out of scope is set for reservations.
Yep. Very reasonable, way to do it. I've seen that in production many times, both v4 and v6, where you're doing a reservation. So that, and again, if you need to swap out a box, you just have to change the MAC address or the DUID on the server, so that you know this is the new device. But then you get the same address over and over. Nice kind of centralized control. Then again, if you've only got one server on your network, then maybe it is easier to manually configure it. Or you've got some kind of boot up process where you're doing, during your imaging, you've got config files that are being imported from some standard repo. Lots of good questions. Yes?
Can RA or Slack hand out resolvers now?
Yes. You can get your DNS resolver either through both DHCP or router advertisements. I think I tried to say that was a surprisingly late addition to router advertisements. It took a long time, and there was an argument for a while that no, the router is authoritative for what addresses are local, but it's not authoritative for your name server. That's someplace else in the network. And kind of at the IETF, we're kind of shouting at each other about, well, then how am I supposed to get that? Well, manually configure it on your device. What? Yeah. So we finally, I want to say RFC 8006. I don't know why that's the number that's sticking in my head there. But so yes, you can absolutely, it is. And there's a whole bunch of other options that have been later added to router advertisements to, again, give you a little bit more flexibility to make it more manageable as in DHCP, as we're used to.
Especially on Linux.
Yeah.
Microsoft's behind on a lot of things.
I'm going to mention send. So I talked about, right, I know. I'm going to mention it because you might read it someplace, ignore it. Secure neighbor discovery, it was to defend against somebody pretending to be a router and sending out neighbor discovery messages. But the problem is, it was designed by Cisco, only ever implemented by Cisco, covered under patent, and it requires a certificate for every LAN segment between you and the server.
It was a Microsoft.
Was it Microsoft?
It was a Microsoft individual that was in the meetings.
Yep.
And they basically took all that information, put it into a patent, and actually shipped it that night. And then the next day, they said, well, we can't talk about this. And this has been, in fact, everybody tried to do this, but Microsoft wanted money for it.
Yeah.
So.
It's, I also, in addition to being proprietary, it's a lot of overhead for not really enough security in most people's opinion. Yeah.
So earlier before you were talking about neighbor discovery blocking it from entering. Can that cross a network boundary?
So if you've got, so neighbor discovery, there was an early vulnerability that's been patched everywhere where you could send neighbor discovery packets remotely. And I don't.
The device that you're adjacent to?
No, from, do I have I thought I had a.
I didn't think they could route.
So it would have been a, I think I remember what it was you would send a packet with a source address of a link local address. Yeah, so exactly, it's smurfing.
But from a general, without getting cute,
Yep.
network stats or anything else, the image discovery protocol does not route,
Right,
just like R.
right,
does not route.
yep.
Okay.
Because it's using link local,
Yeah.
and that's, yep.
That was my understanding. Thank you.
Okay, so there is, you're not going to use send. You can use RA guard, which will gives you a couple of different ways to say this is the router, and so don't let anybody else pretend to be a router. Probably not critically important. Source address verification, kind of similar. This is your protection against that Smurf attack. It's very similar to what we use in v4. Is don't allow bogus source addresses. Like if you've got a packet coming in from outside your network and it's using a source address from inside your network, don't forward that packet. It's obviously spurious. A couple of different algorithms there, and I'm kind of skipping through this because slides are available online. This is networking stuff more than system stuff, and you can come back to this later. Yes, Darren?
So moving this back into, so you come in companies and you help them monetize their v4 assets and show them a way to, or suggest they move to v6. There was a question earlier, and very few of us raised our hands
Right.
about v6 implementations. Besides the straight, hey, you're going to get this bag of money for your v4 addresses, what is your selling point on just in general getting people to move to v6? I've been in this echo chamber apparently for 20 plus years, and you have too, about, though you straddle it a little differently now, where I thought everybody ran IPv6 because I've been doing it since 2002
Right.
for every job I've had.
And it is really funny when I talk to buddies at Facebook, and we're talking about, I did this again at Nanog last week. Ray was our security guy, went to Facebook, and met up with him for lunch a few weeks later, and we're talking about how are things going and what are you working on. He's what's funny, Lee, is there are weeks that I forget that IPv4 exists because Facebook is entirely v6 only inside their network. And I was talking to somebody last week, MJ, who said, well, yes, but I run the only v4 networks that Facebook owns now, and those are because they are the AC units, the backup generators, it's the Internet of junk. So yeah, they still have that. But so these are really and this is, why is Facebook doing this? Because, especially on Android, it saves a few milliseconds. A few milliseconds of performance that correlates to more dwell time on Facebook. And so they can show you more ads, they can sell more stuff, they make more money. LinkedIn is the other one that is famously v6 only, entirely inside. I'm going to talk about how to get to a v6 only server in a minute. But that's those are the big, to me, the drivers is the speed. The dual stack is great. We talked about happy eyeballs, making sure that you can use the best path of whichever is available. But if you're running the network, it's two things that can go wrong. Yeah.
Well, right, that's kind of my point. And you talk about ripping v6 out, because it's something else that, and be very nebulous to troubleshoot. And you've seen it before. You remember at TWC, a truck roll makes somebody
Yeah.
profitable for X amount of time as a
Right.
customer. So I assume the same holds true around help desks.
Right.
So
And that's the other problem. Like, I may, from a fundamental standpoint, understand how IPv6 works. 90% of my coworkers don't know
Right.
what a hex is.
Which is why I keep doing talks like this.
Right.
But this is another reason to at least not ignore v6. You can explicitly rip it out, and it'll work for many things. There's an operating system vendor that is based in somewhere on the West Coast that tells you not to disable v6 because it has things that depend on it. But this is a case that I think is it's kind of scary. So I've got a user at home, like somebody's working from home, and they're connecting to the VPN in the office. What you're supposed to do is any traffic going anywhere in the internet is going through the VPN concentrator, right? All of a sudden, that user at home gets IPv6, but the VPN device, the VPN software, a client, doesn't know anything about IPv6. So it's forwarding all IPv4 traffic to the VPN concentrator and all IPv6 internet traffic to wherever else on the internet. And you, as the VPN administrator, I don't think there's a way for you to tell that remote device to turn off v6. I don't think you have that authority in most cases. You can use a remote control protocol, but generally not the VPN client. So at the very least, pay attention to v6 because all of a sudden you've got this new vulnerability that you had never had before. So there's another motivator. Happen to be with the next slide.
So I'm not a network guy, but it seems like v6 doesn't have anything inherently
No.
better. It was like kind of a necessity, obviously, because they were running out. But I always thought maybe because it's a newer protocol, that they would add some better features to it. But
Lots and lots of debate about whether, there's a T-shirt that says 96 more bits, no magic, and because neighbor discovery, the Slack, that's a little bit different, but is it significantly better? The only argument for it really is that the local router is authoritative for the local network information rather than a server someplace else out somewhere. But no, there aren't a whole lot of inherent features to v6 that make it inherently better. And part of the reason for that is that the internet protocol is designed to be pretty small and pretty simple so that you can move other things around it. So you can do TCP or UDP or QUIC or ICMP, or you can use Ethernet or Wi-Fi or any other layer ATM. You can use any other transport technology. So the question is, we tried to keep IPv6 to be very lightweight and very similar to IPv4 in most respects. And now you get into so there's no motivation to move to IPv6. And so there are some like this, and the business case blogs I pointed to earlier. But no, there's nothing inherently better about it. Go ahead.
Layer 2?
Yeah.
I guess you've seen the Ethernet cards that now support 4 gig packets for lots of data, specifically around the HPC domain.
Mm-hmm.
That's actually a big deal because even backups and other things, you can encrypt one packet, drop it in for whatever the content is, and that basically solves a class of problems that we've never been able to deal with. We're still at 1500 or on most systems, or 9K, which depends on which vendor, the size, and everything else. So
Yep.
that's a big issue. The NAT issue.
Yep.
It actually increases the power utilization. So if you have IoT devices, you're actually running the battery down all the time with every single packet.
I saw that paper recently, yeah.
So, and they calculated that just the IoT, that's 4 additional nuclear power plants that
Wow.
have to be set up per state
Global,
for us to be able to do that.
Wow.
So,
Okay. Yep. We
Follow up on the question about why v6 and v4, what the difference is. There are 2 things that I think that affect us. One is that a lot of stuff's been backported v4 that was in v6 first. But the other piece of folklore which you might want to address is supposedly v6 with extension headers was more efficient for router.
Yeah.
Right?
So yeah, because that's networking, I wasn't going to talk about extension headers.
Do you think the folklore about the routers doing better with v6 versus v4, has that panned out? I haven't seen any evidence that
routers perform any better or worse with v4 and v6. People said, well, it's 4 times as many bits. It's going to take 4 times as much processing time or power, but it's microseconds. It's unmeasurably small if there's a difference. I've been told to speed up a little bit.
Cisco 2000 or something where memory was that much of a thing, but these days routers are almost as powerful as your
Yeah.
latest desktop PCs.
Right, or more depending on, yeah. Yeah. I mentioned ICMPv6 where you need to be careful if you're going to be blocking ping. You can block ping, but you can't block all ICMPv6. That's just a more detailed requirement there. I talked about mail servers briefly on government networks. So I didn't provide my source here, sorry about that. 22 out of the top 50 sites in the US have IPv6 MX records. There are lots of countries where 70 or 80% of mail servers are reachable over IPv6. In almost every case, those are being operated by Google. So Gmail is getting things done there. Fighting spam is a little bit challenging. As I mentioned before, there is a best current operating practice being deployed, or being developed right now, so we'll see how it is. And for exactly the reasons I mentioned before, that if you're blocking an IP address, you don't know how much to block, which is back to IP addresses are not good identity information. Most of your security tools will work just the same with IPv4 and IPv6. You might need to use ping 6 instead of ping, depends on your version. You might need to use traceroute 6 instead of traceroute, depends on your version. And then there are some specific tools, security tools, THC toolkit, and FT6. There's some other things now. I'm sure Joe will give us a long list if you'd like to hear the list. I wrote this, and I disagree with this statement. Running dual stack network doubles the attack exposure. As a malevolent person now has 2 attack vectors, v4 and v6. I don't think it's quite double. It might be a little bit more. It is a little bit more work to operate a dual stack network because you've got, you're going to go roll out a new image. You've got to test the v4. You've got to test the v6. You've got to do a little bit more testing, but you don't have to test everything. You only have to test the networking. So maybe a little bit more. Yeah.
This is naive, but do you always have to have dual stacks to support v4 and v6?
Nope. So because we're short on time, I'm not going to go to depth here, but there's a variety of transition technologies. And this is in the, I mentioned the OMB mandate. It says you must be running IPv6 only. That doesn't mean that you can't also be running a transition technology. One of them that I thought might be applicable is called SIITDC for Stateless IP ICMP translation. And essentially, I'm not going to go through it in detail, but essentially what it does is it's got a mapping that says if I get an IP address, an IPv4 packet coming in, I can send that. I've got a mapping that says I know which server to send it to, and I'm going to forward it there. And when something comes back, it's going to have and I'm going to use a source address with an embedded IPv4 address. So when I get the return packet as the translator, I know to strip out the IPv6 and forward it to that embedded IPv4 address and send it back. That's one example. There's NAT64, very simple. It just translate IPv6 to IPv4. It's stateful, so it's not the best performing technology. And there's mapping address plus port, which is MAP. 2 versions of that does work very well at big scale. Yeah.
That picture looks just like that, except you store all the state and the IP address that you remap it to.
I think of it being more like a load balancer, but yeah, it's
So it doesn't need to maintain any state because it rewrote the. Okay.
it's stateless because you're embedding the v4 address in there. Yeah, but it's just an overwrite. Yep.
I don't mean to cut you short. I do need my laptop.
Oh, okay, I'll let you go. So when you download the slides, you've got some recommended reading, extra credit reading, and feel free to find me online and ask me email questions. I do have, as you might guess, I've got a 3-day class. I've got much more that I can talk about IPv6, and I'm happy to stay and chat for a while, but Andy needs his laptop.
Thank you, Lee. Much
Absolutely.
Yeah, if you want to answer a few more, I don't think you need slides to do any of the question Q&A here, but if anybody that wants to stay around has a few more questions, which it looks like we do.
Apparently so.
At your pleasure.
What an incredibly engaged group. I love it. Oh, good. I love softballs.
What happened to IPv5?
IPv5 was, it was not an internet protocol. It was an IP streaming protocol. And so the number was reserved at IANA in the protocol parameters. And so just like Star Trek movies, only the even ones are any good.
Check Wikipedia for the history of
Yeah.
what was IPv8 was suggested by the Chinese 256-bit number.
So yeah, I mean, I have seen people, I've seen people propose protocols as high as IPv12. They usually get shouted down as being, you don't get to pick your protocol number. You get to propose a protocol. Variable length addresses have been proposed, for instance, and the trouble with that is if you're a forwarding device, if you're a router, how do you figure out how much is prefix, how much is network number, and how much is host number? It gets pretty complicated.
You don't have to TLB, then you can use arbitrary length.
Say that again?
Type length value.
Yeah,
then the address length can be arbitrary.
Sure. If you completely change the data structure of the Internet Protocol packet, then you can encode different information in it, and you could say this set of instructions is the network number. Still think you have the difficulty of having to do a lot more parsing of the data packet in order to figure that out. You had a question.
Yes, this is kind of weird. So I was, a couple of weeks ago, maybe within the last like 3 months, I can't remember what I was looking for originally, but I went down a rabbit hole and found this thing on Reddit, where a guy said he talked to his ISP, because he wanted a static IPv6 address, and they gave him like some like insane number of them for free. It was just like, it was like crazy. He's like, I could hook, I could buy, 1,000 things and have each have their own IPv6 address. So I was like, that sounds cool. I want to do that. So I went to the website for Verizon, who's my ISP, and looked around, and all I could find was a statement saying, once all the IP4 addresses are done, we'll get around to IPv6.
So Verizon Fios is now 33%, is what I showed at the beginning. 33% of Verizon Fios customers are now able to use IPv6 to hit Google and whatnot. So they're not 100% there. So they are starting the deployment, and actually fairly deep into the deployment, but they're not done yet.
I mean, this was like only a couple of weeks ago.
Yeah. So I mean,
They had none.
so yeah.
I'm not aware of any residential service, and there may be some out there that give away static IPs.
Well, yeah. So
I'm not saying that there aren't.
Yeah.
I've never run into one.
Yeah.
To
So
get a static IP from Bright House when I lived in Florida, you had to be on what they called a residential business account.
Right.
And back then you got an included IPv4 address.
right. The good news, bad news is that I don't know of any ISP that's charging for IPv6, unlike a static IPv4 address where they may charge you 12 or 24 bucks a month for an address.
Oh, it was included in the service.
Oh,
It was
wow.
a wild time.
So, yeah, back in the Wild West. So, yeah, but I agree. I haven't seen a residential service offer a static reservation.
The reason I'm going to follow up with that is most residential internet service providers, in their terms of service, it's explicitly stated you're not allowed to run servers
Right.
on your service. Now, most ISPs won't actually come for you.
They're not looking for you, but
Comcast and Embark
Yeah.
and CenturyLink used to do all sorts of wild packet shaping when it came to VoIP and SIP
and BitTorrent was sort of the big one,
Well-
and the reason being that they've got asymmetric bandwidth, and so they're building their profiles on, we expect a certain number of users to use a certain amount of bandwidth upstream and downstream, and now you're inverting our models, and so we can't provision properly. So not just because they're evil. There were reasons for putting those terms in the contracts,
Well, the
but
packet shaping on the SIP stuff was because they sold a service.
yeah, that's evil.
Yeah, that is evil.
Yeah.
I mean, I get the BitTorrent stuff.
Yeah.
I'm not going to complain about them trying to track that stuff. It's when they,
Yeah,
either
but-
packet shape Netflix or they packet shape.
But and SIP is,
SIP
there's just no bandwidth there. Who cares? It's what, 64K?
I'm
I mean,
talking about like what, 10,
Yeah.
15 years ago when
I mean,
VoIP was the new.
right. I suppose if you're on ISDN, maybe you care about. I don't know. Yeah. I think I saw other comments, hands. Anybody?
Great presentation. Thanks for coming.
I thank you so much for being engaged in comment.
IPv6 out. Most people don't know IPv6, and it's network persistence. So, I mean, I get the. I don't know when in the last 3 years, Kubernetes did not like IPv6 for a long time. That I remember.
Yeah, I haven't been much into
Kubernetes.
containers.
Like just now recently, the CNIs for various Kubernetes distributions will support dual stack, but there was a very long period where like, if you were trying to run IPv6, it was just going to vomit on you.
Yeah, I can